Afternoon, everyone. So today is lovely day, right? Earlier there was mini exhibition. Class 9 they have done wonderful exhibition. You can check the video. One group has made near about 4 presentations. So what was the presentation? After watching, you can find out their explanation, this and that. It was okay. Just learn from them. Some you have to learn from class 8. Some you have to learn from class 9 also. They are also as busy as you. Don't think that, sir, we are much busy. Okay. So today there is presentation from Newton group. So who is going to present? Sashank Acharya. Okay. Give him a big round of applause.
Lamsal.
Now if you make a louder one, then it will play nice.
Namaskar and everyone. Good afternoon to all. Today I am here to discuss on the topic of electricity and magnetism. I am from Newton Group. First topic is electric motor. We know that when electric current passes through a conductor, a magnetic field is produced around it. If the conductor is kept in a magnetic field, there is a mutual attraction or repulsion between the magnetic fields due to the magnetic effect of the current carrying conductor and magnetic field of the magnet. Transformer. A transformer consists of a rectangular soft iron core made of a number of laminated iron sheets. There are two coils having different numbers of turns which are not connected to one another in any way. The coils are wound on the iron core. Here is one formula derived from working methods. Np by Ns equals to Vp by Bs. Thank you.
Slides only, right? So much more explanation was not there. Why? Explanation should be more, no? So there are different things like you just mentioned electric motor. There must be motor details also. Then the transformer mentioned. Then type of transformer, step up transformer, step down transformer, and transformer equation, right? So while making the slide, you have to deal on all those things. Then the presentation will be quite better. So your presentation is from here. Let's check here. Class 8, right? Class 10 this one. What are you writing, boy? One walk at a time. I will allow you to write after some time. Don't worry. You might have thought that teacher won't give work. I will give you work. And you have got from today new word. What is that? BBA. BBA is very, very important because practice at home is very essential. So Saturday's work you have to submit over there. So children, so he brought from here electric motor. What is here? Electric motor. First of all, we have to know what is electric motor. What is electric motor? You were just using one motor there, DC motor you said. So electric motor is a device that converts electrical energy into kinetic energy. There is also kinetic energy. See, electricity is supplied, that's why it's functioning. Will you make it off? Switch off. Now see, it is off now. But it is continuing because of inertia of motion. Inertia of motion. Now switch on. Otherwise it will spin this one. So electric motor converts electrical energy into kinetic energy, and it is based on one principle. Electric motor is based on one principle. What is that principle called? Motor effect. What is the principle called? Motor effect. Is given there somewhere else motor effect? Children, is it given somewhere else motor effect or not? Yes. Here is motor effect. Check here. What is this? You check here. When a current carrying conductor is kept in a magnetic field, the conductor moves if it is allowed to do so. This is called principle of motor effect, or simply we can say motor effect. I mean, we know that. Suppose if it is connected like this, right? Then what is flowing through it? Current is flowing through it. And if we keep here one magnet, what is kept here? One magnet. If magnet is kept here, see this magnet also has got magnetic field. This wire also has got magnetic field. If so, two magnets, if they are brought together, there may be either repulsion or attraction. Yes or no? So, as a result, this conductor vibrates. This conductor vibrates. That effect is called motor effect. So, that is also working because of vibration of that conductor. So, mainly how many types of electric motors are there? How many types are there? Two types. What are they? One is DC motor, another is AC motor. DC motor and AC motor. So there are many devices where motor effect or electric motor is used. Like it is used for pumping the water in our home. Water pump. In village also they use big water pump set they say. That is also based on motor effect. I don't know, do you have this washing machine or not? Washing machine is there, right? Washing machine is based on motor effect. Vacuum cleaner is also based on, what is that? Motor effect. Girls, they use that hair dryer. Does it vibrate or not? That is also based on motor effect. Many devices are based on motor effect, right? These engines of vehicles of electric car is also based on motor effect, right? Electricity is supplied, then the motor runs and it moves like that, right? But if we talk about fossil fuel, we have to supply petrol or diesel so that it rotates. But over there, no petrol, no diesel, so it's just electricity. Electricity is converted into kinetic energy, then it moves. Okay, that is the thing. Here is one device. You have seen this one in the pole. Transformer. What is transformer? First we have to know. Transformer is the device that is capable of altering the magnitude of AC voltage. It may increase the voltage or decrease the voltage. If there is low voltage, we can change into high voltage. If there is high voltage, we can change into low voltage. So, but one thing you have to keep in mind, transformer can alter the voltage of AC current only, alternating current only. Why? Because it has frequency. If it has frequency, it can be altered. If it has no frequency, it cannot be altered. So, one thing you have to remember, there are mainly two types of transformer. What are they? Step up transformer and step down transformer. In transformer, actually there is primary coil and secondary coil. In transformer, what is there? Primary coil and secondary coil. Primary coil means that is winding of wire where current is supplied. Current is supplied. From secondary coil, we can get output current. Input current, here output current. Okay. Always this primary coil is connected to the AC voltage that is connected with the roadside voltage, isn't it? And this secondary coil it supplies electricity to the devices which we use in our home, whether for refrigerator or television or rice cooker, whatever you are using. So that is connected in secondary coil. And he has mentioned one formula here. What formula I mentioned? NP by NS. So what are those NP, 1 NS? So here are turnings. Can you see here this windings? Turns. So the turns in this side, primary side, there are primary turns. This one, secondary turns. Number of turns are equal or unequal? Number of turns in this primary coil and secondary coils must be unequal. If equal, then that is not the transformer. Why? It cannot increase the voltage, it cannot decrease the voltage. Same voltage means what is the connecting this one? Just use one wire only. So, to either increase or decrease, we have to use transformer. Now see, look at this one. In this figure, primary coil contains less number of turns. Secondary coil contains more number of turns. This type of transformer is called step-up transformer. Oh, already name is given here. What is it called? What does step-up do? It increases the voltage. Suppose there is 50 volt, you want to change into 200 volt. Then step-up works. Another transformer is there. What is name? Step down. What does step down transformer do? It decreases the voltage. So see, coils are more here, coils are less. So if you have to differentiate between step up and step down transformer, how do you differentiate? Step up, primary turns are less, secondary turns are more. Step down, primary turns are more, secondary turns are less. Be interactive. Eh? Step up increases the supplied voltage. Step down decreases the supplied voltage. Step up, it is used in hydroelectric power stations. What is it used? And this is used for domestic purposes. Domestic purposes. NP, number of turns in primary coil. NS, number of turns in secondary coil. VP, primary voltage. What is that? Primary voltage. VS, or NP means primary turns, secondary turns, primary voltage, secondary voltage. This relation you have to remember. Right? Remember the formula, what is that? NP by NS equals to VP by VS. NV. Left hand side N, right hand side V. PS. Very simple. One numerical problem is given. What is the numerical problem? Read the question here. Number of turns in the primary coil is 1600. Number of turns in secondary coil is how much? 240. Primary voltage is how much? 220. Then secondary voltage how to find? Which formula we know? NP by NS equals to VP by VS. What is NP? What is NS? If you write, then finally you can get it. Sometimes your answer may be here in decimal point. Then you have to round up. If it is more than 5, you just go to higher level. Otherwise, you remain there only. These are the numericals, and this chapter also more or less completed. See how fast is done. So today I'm not going to provide you more homework because you have got duty to practice many more sample questions of those students who have already performed also. Or you can prepare yourself and practice, and you have to write also. Writing is very important. Remember, I'm not going to listen that, sir, I read only, no. Write and read, so that you can show the proof. These numerical problems only will do. Is that okay? Please read first question. What is given? Multiple choice question. Number A. Okay. Which group want to say? Okay. A, B, C, D, E. There are 5 questions. Okay. Choose yourself. Who want to solve? Which group want to solve? A. Group A. A. No, not group A. What is your group? Einstein. Okay, what is the answer? Tell me, number A. Einstein, what is the answer? You belong to Einstein? Okay, or state. They said or state. We'll tally later on whether right or wrong. Okay, group B want to solve? Number B want to solve. Hello, which group? B. What are they doing? So nobody wants there. Group, okay, tell. Which group are you in? Mendeleev. Okay, Mendeleev is going to say. Transformer. He said transformer. I have not checked, so we'll check this later. Okay, who wants to solve number C? Number C. Okay. Thermal power plant, he said. Number D. Want to do number D? Okay, Sapan again wants to say. Third one. Number E. Number E, wind power plant. This is right. Okay, let's check whether right or wrong. Read question number A. Who discovered the magnetic effect of electric current? Who discovered? Oersted. That's right. This is correct. If it is circled, means it is right, right? Number B. Which instrument converts lower AC voltage into higher AC voltage? And vice versa. What is the answer? Transformer. I think it is right, right? Number C. Which instrument provides electricity in a large scale but causes pollution? Right, what you said. Because in thermal power plant, diesel, petrol, etc. they burn. When they burn, they produce carbon dioxide and other harmful gases as well. Yes or no? This is right. Eh? Number D. Who discovered that there is a change in magnetic field linked with the closed coil and EMF is induced in the wire of the coil? Faraday. And this is wrong. Oersted is wrong. Which one is correct? Faraday. So Faraday is the candidate who propounded electromagnetic induction. Who propounded electromagnetic induction. Now number E, in which of the following are fossil fuels used? Thermal power plants. This one is okay. This is wrong. But did you mark in your book? Okay. Now how many more are there? We will be discussing. F, G, H. Now who want to say F? Okay, any group you can just tell me. Third, okay. Sapan said third. Sapan. This is Sapan. Number G. Are you find out? Oh, future science. Number. Third one, Ritika said. Now number H. Oh no, who said? Nirajan said. Which one? Second. No, Nirajan said the idea. Right? For what purpose is the right hand grip rule used? Grip, right? Not thumb. Right hand grip means that is, I think solenoid must be there to determine magnetic field of a solenoid, right? Solenoid, just remember. Right hand thumb for current and magnetic field, but here magnetic field of a solenoid. That was a conductor, this is right. Number G, Ritika said, which of the following is used to find the direction of lines of force around a straight wire? Right and thumb rule, right? That's right. Okay, this is also correct. Number H, which of the following makes our country rich in hydroelectric power? Presence of number of rivers, that's right. Because of rivers, no? Yes, okay. That is all. So you can start doing the work.